Most people picture Iran flat. Sand, heat, a low country lying somewhere between the rivers of Iraq and the warm water of the Gulf. Dunes, and a horizon with nothing standing on it. The heat part is right. Roughly 90% of this country is arid or semi-arid. The national average rainfall is about 250 millimeters a year. In the deep interior, it falls below 130. In some basins, it barely reaches 25. And in 2005, a satellite passed over southeastern Iran and measured the ground. 70.7 degrees Celsius. The hottest land surface ever recorded on this planet. Not in the Sahara, not in Death Valley. Here. So the heat is real, the dryness is real, but the flatness is not. Iran is one of the highest countries in Asia. The interior is not a lowland at all. It is a plateau, sitting around 900 meters above the sea. 16% of the country stands above 2,000 meters. Mountains and desert together take more than half the map. And on the northern rim, a single volcano rises to 5,671 meters. Damavand, the highest point on the whole Eurasian landmass west of the Hindu Kush. You can see it from the capital on a clear morning. Look at Iran from orbit, and the shape becomes obvious. There is a rim, a raised edge, running almost the entire perimeter of the country. Ridges in the west, ridges in the north, ridges in the northeast, and again along the southern coast. And inside the rim, sunk into the middle of it, the emptiest ground in the Middle East. That is not a coincidence. The deserts in the center of Iran are not there because the latitude demands it. They are there because the mountains put them there. Every wet wind that reaches this country from any direction hits rock first, climbs, cools, drops its water on the outward slope, and arrives on the inside with nothing left to give. The wall does not keep people out. The wall keeps the rain out. Which raises a harder question, because 90 million people live in this country. Cities of millions sit in the middle of that dry interior, on a plateau that its own mountains have sealed off from every sea it borders. Where do they get the water? Why does an entire nation live behind a wall of mountains? And what did that wall give them in return? Start on the outside of it. There is a strip of land in the north of Iran that does not behave like the rest of the country. It runs east to west along the southern shore of the Caspian Sea, 850 kilometers long, and at its widest, less than 50 kilometers deep. It rains there. Not occasionally, constantly. The Caspian coast takes between 800 and 2,000 millimeters of rain a year, spread across every season, in a country where 70% of the rainfall arrives in a single window between November and March. 2,000 millimeters. That is more than London, more than Dublin, more than most of the temperate world. And then you cross one ridge. South of that strip, the ground climbs into the Alborz, and on the far side of the crest, less than 100 kilometers from a coast that gets 2 meters of rain a year, the annual figure drops below 300 millimeters. Keep going, and it drops below 130. Two of the wettest and driest places in Western Asia, sitting within sight of the same mountain. That single ridge is the whole story of this country, compressed into about 90 kilometers of ground. And to understand what it does, you have to understand what it is made of, and why it is standing there at all. The Alborz is narrow, and it is high. It curves along the Caspian shore like a drawn bow, from the Azerbaijani border in the northwest to the ranges of Khorasan in the east. Peaks well above 4,000 meters. In the center, Damavand, a dormant volcano with a snow cap that lasts most of the year. Air coming off the Caspian is heavy with moisture. It moves south. It reaches the wall, and it has nowhere to go but up. Rising air cools. Cooling air cannot hold water, so the moisture condenses on the northern slope and falls as rain. And by the time that air spills over the crest and descends onto the plateau, it has been wrung dry, and it is warming again as it drops. Warm. Descending air does not rain. It evaporates. So the Alborz does two things at once, with the same act. It waters the north coast until the forest there is almost tropical in density, and it starves everything behind it. One range, two climates. No middle ground. What grows on the wet side of that wall has been growing there a very long time. The Hyrcanian forest covers the seaward slope in a single, unbroken arc. Broadleaf, dense. Beech, hornbeam, chestnut-leaved oak, ironwood, elm, alder. Fog sits in it for most of the year. It is roughly 25 to 50 million years old. Forests like this once covered most of the northern temperate world. Then the ice ages came, and across Europe they were erased, pushed south, squeezed against the Alps and the Mediterranean, and killed. What replaced them was tundra, then steppe, then the young forests we know today. The Hyrcanian never died. The Caspian held the temperature. The Alborz blocked the cold air coming down from the north and the dry air coming up from the south. Between the sea and the wall, a strip of humid ground survived every glaciation the Quaternary produced. Species that exist in Europe only as fossils are still standing here, alive, with leaves on. Botanists call it a refugium, a place where the past kept breathing. It covers about 7% of Iran. It holds 44% of every vascular plant species in the country, 180 bird species, 58 mammals. Some of the individual trees are 300 to 500 years old. And it is the only part of Iran where a farmer can plant a crop and simply let the sky water it. Rice grows here. Tea grows here. Silk was made here. Everywhere else in this country, agriculture is an act of engineering, a decision to move water from somewhere it exists to somewhere it does not. On the Caspian Strip, it is just farming. Which is why the density here is what it is. Gilan and Mazandaran are the most crowded rural provinces in Iran. More than 130 people per square kilometre in Mazandaran. In the southeast of the country, the figure falls to 1. 1 person per square kilometre. The same nation, the same century, 100-fold difference in how many people the ground will hold. And the reason is a mountain range. Climb out of that forest and the trees thin fast. Above the tree line, the slope turns to bare rock, scree, and near vertical faces where nothing can stand. Except something does. The Bezoar ibex is a wild goat, and it reads a cliff the way most animals read a meadow. Males can weigh 90 kilograms and carry scimitar horns more than 1 metre long. They live on the exposed faces of both Iranian walls, the Alborz in the north and the length of the Zagros in the west. At altitudes where the air is thin and the ground offers no cover at all. The hooves are the trick. Each one splits with a hard rim and a soft, rubbery pad in the centre that grips stone the way a climbing shoe does. They can stand on a ledge the width of a hand. Nothing about that is comfort. It is calculation. There is no shelter on a cliff, no water on a cliff, and almost nothing to eat on a cliff. What a cliff has is an absence of predators, because a wolf cannot follow you onto it. So the ibex trades food and safety for slope. It comes down to feed. It goes up to live. This is the animal every domestic goat on Earth descends from. 10,000 years ago, in these same Zagros valleys, people began keeping them. The wild version is still on the rock above the villages of the tame one. The land here does not offer good options. It offers a choice between hard ones. And everything that survives has already chosen. Above the ibex, above the tree line, above the clouds on most days, the top of the wall. Damavand stands alone. 5,671 metres, a near-perfect cone, sulphur venting from fumaroles near the summit, and a permanent snowfield draped over the top of it. It is a volcano, and it is not extinct. It is dormant. There is still heat under it. In Persian mythology, it is the centre of the world, the mountain where a tyrant was chained and where a hero was raised. Almost every version of the old stories puts something enormous inside it. Geologically, what is inside it is water. That snowfield is a reservoir. Every winter it takes on mass, and every spring it releases it, slowly, into the rock beneath. The Alborz as a whole functions the same way. A long, high, narrow structure that catches winter precipitation as snow, holds it through the cold months, and then lets it out in a controlled melt exactly when the plateau below is heating up and drying out. The mountains take the rain from the interior, and then, on a delay, they give a fraction of it back. That fraction has to go somewhere. Meltwater runs down the southern flank of the Alborz, spreads out where the slope flattens, and soaks into the coarse gravel of the alluvial fans at the foot of the range. It does not stay on the surface. On this plateau, surface water in summer is a temporary condition. Evaporation here runs several times higher than rainfall, so anything exposed to the sun is on a countdown. But underground, in the gravel, it keeps. And now a question worth holding on to. Water goes into the ground at the foot of the mountains. Water is needed 100 kilometres out, in the middle of the flat, where nothing falls from the sky at all. Nobody here had a pump. Nobody had a pipeline. Nobody had a river to divert, because on the plateau there is barely a river worth the name. The streams that form from snowmelt run dry for most of the year and end, when they end at all, in salt. So how do you move water across a desert, in a climate that will steal it out of the air before it arrives? The answer is visible from an aeroplane, and almost nobody recognizes it when they see it. Before that, the flat itself. The center of the Iranian plateau is occupied by two enormous basins. The northern one is the Dasht-e-Kavir, the Great Salt Desert. Around 77,000 square kilometers of it. That is larger than Ireland, and almost nobody lives on it. It is not a sand desert, it is a salt one, and the difference matters, because it explains how it was made. Every spring, meltwater comes off the ranges that surround this basin and runs downhill toward the middle of it. That water has nowhere to go. The Kavir is what geographers call an endorheic basin, a closed drainage system with no outlet to any sea. Water enters, water does not leave, so it spreads out across the floor in a shallow sheet. And then the summer arrives, and the sheet evaporates. What the water was carrying stays behind. Salt, dissolved out of the rock upstream, deposited layer on layer, year on year, for tens of thousands of years, until the floor of the basin is a crust of it. In places, that crust is hard enough to walk on. In places, it is a thin plate over black mud that has never dried, and stepping through it is the last thing you do. So this desert was not built by an absence of water. It was built by water, arriving, dying, and leaving its cargo on the floor. The surface tells you the same story in its shape. Polygonal plates of salt, meters across, buckled upward at the seams where the crust expanded against itself. Mudflats that shine like water and are not. Nothing green for 100 kilometers in any direction, because almost no plant on Earth can pull fresh water out of brine. The temperature swing on that floor can exceed 50 degrees between the afternoon and the hour before dawn. There is no vegetation to hold heat and no cloud to trap it, so the ground takes everything the sun gives and then throws all of it back at the sky the moment the sun is gone. And yet, from the air, across some of that ground, you can see lines. Not roads, circles, small, dark, evenly spaced, running dead straight across the emptiness for kilometre after kilometre, sometimes for tens of kilometres, ending nowhere in particular. Hold on to those. They are the answer to the question the mountains asked. Because the interior of Iran is not entirely empty, and where it is not empty, the reason is never obvious from the ground. The edges of these basins are a different matter. Where the salt flat runs out and the ground begins to lift toward the surrounding ranges, there is a fringe, semi-desert, steppe, thorn scrub, a few centimeters of rain more than the floor gets, and a few degrees less heat. That fringe is where the large animals are. The Persian leopard is the largest leopard subspecies alive. A big male can exceed 90 kilograms, heavier than any leopard in Africa or India, with a thick, pale winter coat that goes almost grey against limestone. Draw its range on a map of Iran, and you have effectively drawn the mountains. The Alborz, the Hyrcanian forest belt on the wet side, the long spine of the Zagros, the ranges of Khorasan in the northeast. It follows the rim of the country almost exactly, and it avoids the middle. The reason is the ibex. The leopard's main prey across most of this country is wild goat and wild sheep, and wild goat lives on cliffs. So the predator has evolved into a cliff animal too. Shorter in the leg than its lowland relatives, heavier in the shoulder, built for ambush on broken ground rather than a chase across open country. It hunts by getting above something and dropping onto it, which means the geography that made the ibex made the leopard as well. The wall raised the goat fed the cat, and the cat became the shape of the wall. There were once other predators here. The Caspian tiger lived in the reed beds and forests along the southern Caspian and up the river valleys of the northeast. The Asiatic lion lived in the oak woodland and the plains of the southwest. Both are gone from this country, and from the world in the Caspian tiger's case, by the early part of the 20th century. They are not coming back. That is simply the record. The leopard remains, mostly as evidence rather than sightings, a print in snow, a scrape on a trail, a frame from a camera trap at 3 in the morning. Researchers in the Alborz can work a mountain for years and never see one with their own eyes. It is still on the ridge above the villages. It has been there the entire time. South and east of the Salt, the ground gets worse. The Dasht Ilut runs 480 kilometers north to south and 320 kilometers east to west. 51,800 square kilometers. The name means roughly the plain of emptiness. It is not the largest desert in the world. It is not close. It is somewhere around the 33rd. It is the hottest place ever measured on the surface of this planet. Those two facts sit badly together. The Sahara is 9 million square kilometers, and it does not hold the record. The Arabian Peninsula does not hold it. Death Valley held it once and lost it. A mid-sized basin in southeastern Iran holds it. Between 2003 and 2010, an instrument aboard NASA's Aqua satellite swept the entire globe measuring land surface temperature. Not air temperature in a shaded box at 2 meters, the actual heat of the ground itself. For most of those years, the hottest reading anywhere on Earth came from the same place. In 2005, the number was 70.7 degrees Celsius, 159 degrees Fahrenheit. Water boils at 100. The ground there reached 70% of the way. So why here? 3 reasons, and all 3 are geography. The first is the ring. The Lut sits in a tectonic depression, a basin dropped between rising ground, the product of the same continental collision that lifted everything else in this country. It is walled by mountains on every side. The Zagros and the Makran ranges stand between it and the Indian Ocean. Ranges stand between it and the Gulf. Humid air from any warm sea nearby is intercepted before it arrives. Nothing that could cool this basin can reach it. The second is the absence of plants. Vegetation cools ground. Leaves transpire, shade holds heat off the soil, and roots keep moisture in the top layer. The Lut's soil is salted and the surface is mostly bare, so none of that happens. Climatologists studying the satellite data noted the pattern directly. The hottest readings came from the places with nothing growing on them. And the third reason is a plateau near the center of the basin called Gandom Berian. Around 480 square kilometers of it covered in black volcanic pebbles. Dark surfaces absorb sunlight rather than reflecting it. Pale sand throws a large share of the energy back at the sky. Black basalt keeps it and re-radiates it as heat. So the hottest ground on Earth is not pale desert sand. It is a black stone floor at the bottom of a bowl that the mountains have sealed. The local name for it translates as toasted wheat. The story attached to it says a load of grain was left out there and came back scorched. Which sounds like folklore until you look at the number the satellite returned. Wind does the rest of the shaping. From June to October, the Lut is worked by strong, persistent winds carrying sand. Over long periods, that abrasion has cut the sediment into yardangs, parallel ridges and furrows aligned exactly with the prevailing wind, running for tens of kilometers, some of them tens of meters high. From above, they look like the grain in a plank of wood. Locals call them kaluts. In the east of the basin, the dunes reach 300 meters. That is roughly the height of the Eiffel Tower, in sand. And in the lowest part of the basin, the floor sits around 110 meters above sea level, on a plateau that averages 900. The Lut is a hole in the middle of a highland. nothing lives on the floor of it. Salt crust and heat leave no opening. A few lichens, a tamarisk where there is a seep, and otherwise a surface as biologically empty as anywhere on land. Except at night, and except below. The scorpions of the Iranian deserts have not solved the heat. They have simply refused to meet it. A scorpion on that ground in the afternoon would cook in minutes, so it is not on that ground in the afternoon. It is in a burrow, sometimes only 30 or 40 centimetres down, sometimes deeper. And 30 centimetres is enough. Below the surface layer, the daily swing flattens out fast. A metre down, a desert that ranges from 70 degrees to near freezing in 24 hours holds something close to a steady, survivable temperature. They come up in the dark. They hunt by vibration through the sand rather than sight, take insects, and metabolize slowly enough that some species can go months between meals. They do not need to drink. They take their water from what they eat. It is not endurance, it is avoidance, executed perfectly. The animal did not evolve to withstand the surface. It evolved to leave it. Which is worth remembering, because a few hundred kilometres from that burrow, on the same plateau, under the same sun, human beings arrived at exactly the same answer. They also went underground. On the western fringe of the Lut, in the ranges near Kerman, archaeological survey has turned up dozens of ancient sites, some of them dating to the 5th millennium before the Common Era. 7,000 years ago, people were living on the edge of the hottest ground on Earth. Not on the floor, on the margin, where the mountains meet the flat. Always on the margin, always at the foot of a slope. There is a reason for that, and it is the same reason those straight lines of circles cross the desert further north. Yazd sits on the plateau at 1,237 metres, between the two great deserts, with the Kavir to the north and the Lut to the southeast. It receives 71 millimetres of rain a year. For comparison, London takes around 600. Cairo takes about 25. Yazd sits nearer to Cairo than to anywhere in Europe, on the dry edge of the habitable band, with summer temperatures that pass 45 degrees and an average humidity around 30%. There is no river, there is no lake, there is no aquifer beneath the city worth drilling into, and Yazd has been continuously inhabited for thousands of years. Which brings us back to the lines of circles. They are shafts. Each dark ring is the mouth of a vertical well, and each well drops down to a single hand-dug tunnel running underneath the desert floor. The tunnel is called a qanat, kariz in Persian, and it is the reason this country exists in the shape it does. Here is how one is made. You do not start at the town. You start at the mountains, 60 or 80 kilometres away, where the slope flattens into gravel and the snowmelt has soaked in. A surveyor picks a spot on the alluvial fan and the digging begins there, straight down, a shaft roughly a metre across, sometimes 15 metres deep, sometimes over 100, until it reaches the water table. That first shaft is called the mother well. Everything else is measured from it. Then the direction reverses. From the mother well, a crew begins cutting a tunnel back toward the settlement, horizontally, by hand, in a space barely wide enough for one man to work in. And the tunnel must descend continuously for its entire length on a gradient of a fraction of a percent. That number is the whole engineering problem. Too steep, and the water runs fast enough to scour the floor, collapse the tunnel, and drain the aquifer faster than the mountains can refill it. Too shallow, and the water stalls, drops its sediment, and the tunnel silts up and dies. The margin between those two failures, over 70 kilometers of unlit tunnel, dug blind, with hand tools, is a few meters of fall. The vertical shafts along the lines solve the rest. They let the diggers get in and out. They let the excavated spoil come up. They give air to men working underground for hours. And afterwards, they let the maintenance crews reach any point along the tunnel for the rest of its working life, which, in some cases, has been 1,000 years and counting. Around the mouth of each shaft, the crews piled the spoil in a ring, which keeps surface runoff and dirt from washing back down the hole. That is the ring you see from the air. At the far end, the tunnel meets the surface and the water simply comes out, at the mazhar, the outlet, running clear and cold into daylight after 80 kilometers in the dark. From there, it goes to the fields, the gardens, the reservoirs and the bathhouses, distributed by rules of share and rotation that in some districts are older than any surviving building. It never meets the sun. That is the point of the entire design. On this plateau, evaporation outruns rainfall by multiples. An open canal crossing the Kavir in July would lose a large part of its flow to the air before it arrived. Put it under 2 meters of earth, and the loss goes to almost nothing. The qanat is not merely a way to get water, it is a way to get water in a climate that is actively trying to take it back. And it needs no power. No pumps, no wheels, no fuel. Gravity, applied with enough precision that it will keep working long after the men who cut it are forgotten. The Greek historian Polybius, writing in the 2nd century before the Common Era, described Persians drawing water from a great depth and moving it underground, and did not appear to fully understand what he was looking at. He was describing something that was already old when he saw it. Estimates for the origin of the technique run from 3,000 to 5,000 years. It spread west across the Middle East and North Africa, into Spain, Italy, and as far as the oases of western China, picking up a new name in every language: Fogara, Ketara, Falaj, Karez. The largest surviving working systems are still in Iran. So the picture inverts. The interior of this country is not a place where people scraped by against the odds. It is a place that was read correctly a very long time ago, and then engineered around. The reasoning went something like this. There is no water on the surface, but there is water in the gravel at the foot of the mountains. The sun will steal anything exposed, so do not expose it. The ground is a better container than any vessel we can build. Therefore, we will not bring the city to the water. We will bring the water to the city, underground, on a gradient we can hold. And once you have accepted living inside the Earth's terms rather than above them, the rest of the city follows. The houses of old Yazd are adobe and mud brick, walls thick enough that the day's heat takes until the small hours to work through them, by which time the night has cooled the outside and the direction of flow reverses. The streets are narrow and often roofed, so the pavement never takes a full sun. Courtyards sit inward, with a pool at the center. And above the rooftops, the towers. They are called badgirs, wind catchers. A shaft rising several meters above the roof, open at the top on multiple faces, dropping straight down into the room below. Wind hitting an open face is pushed down the shaft and into the house. On the sheltered faces, the pressure difference does the opposite. It pulls the hot air of the room upward and out. Run the incoming air across the surface of a pool at the base and it cools further, because evaporation takes heat with it. And evaporative cooling works best precisely where the air is driest, which is to say, exactly here. No electricity, no moving parts, a tower and a hole in the roof. Yazd has around 700 of them. The oldest surviving examples date to the 14th century, and the design itself is believed to be far older. The tallest, at the Dawlatabad Garden, stands 33 meters, among the tallest wind catchers anywhere. The same principle was pushed further still. Under a domed structure called a yakchal, with a wind catcher above and a shaded pool below, the plateau's dry night air was used to freeze water, and the ice was stored through the summer in the desert without a machine anywhere in the building. In 2017, the old city was inscribed as a World Heritage Site. The description called it a living testimony to the intelligent use of limited resources in the desert for survival, which is accurate but slightly gentle. This was not survival. This was a civilization that looked at a plateau its own mountains had sealed off from the sky and decided the plateau was workable. Once you know what to look for, the map of this country stops looking random. Almost every major Iranian city sits at the same kind of address. Not on a coast, not on a great river. At the foot of a range, on the gravel fan where mountain water arrives underground and can be reached. Tehran is the clearest case. The capital sits on the southern skirt of the Alborz, on the fans below the range, with Damavand on the skyline to the east. It is not there because of a harbour or a river crossing. It is there because that is where the mountain lets go of its water. Around 1 in 10 Iranians now lives in that city, at a provincial density near 400 people per square kilometre. Tabriz sits in the northwest, in volcanic highland under the slopes of Sahand. Mashhad sits in the northeast, in the foothills of the Kopet Dag. Kerman and Bam sit on the western margin of the Lut, on Qanat water. Shiraz sits in a Zagros basin. Same rule applied 9 or 10 times across 2,500 years. Isfahan is the exception that proves it, because Isfahan has a river. The Zayander Rud rises in the high Zagros, in the massif around Zardku, and runs east onto the plateau. Its name means roughly the life-giving river. The city sits on it at 1,600 meters and grew into one of the largest urban centers in the country. And the river does not reach the sea. It cannot. It is running inland into a closed basin, and roughly 300 kilometers downstream from the city it ends, in the Gavkuni, a shallow salt marsh where the water stops and the sun takes it. That is the plateau's rule in a single watercourse. Water on this highland is not something that passes through on its way somewhere. It arrives, it is used, and it evaporates. There is no outlet. There is no downstream. There is one place in Iran where that is not true, and it is in the southwest, where the Zagros front finally drops. Khuzestan is the lowland. The mountains give out and the ground flattens into the northern edge of a Mesopotamian plain. Hot, humid in summer, brutally so, but flat, and watered by rivers that have somewhere to go. The largest of them is the Karun. It rises in the same high Zagros as the Zayander Rud, gathers the melt off the highest peaks in the range, and runs southwest to the Gulf. It is the most voluminous river in Iran, and the only navigable one. Shallow draft boats can work roughly 180 kilometers of it, from Khorramshahr up to Avaz. One navigable river in a country of 1.5 million square kilometers. So this is the oldest farmed ground here, and the ground where people first tried to argue with the terrain rather than adapt to it. The 3rd century of the Common Era. On the Karun at Shushtar, engineers cut a channel straight through bedrock to divert part of the river, throw weirs across the main stream, and drop the flow through a stepped complex of mills and canals. They raise the water level so it can be lifted onto fields that sit above the natural riverline. They build an island out of the split and irrigate 40,000 hectares from it. Some of that system was still turning mills in the 20th century. The folded rock behind it is doing something else useful, and quietly. As the Zagros crumpled, layer after layer of ancient sea sediment was buckled into long, parallel arches, and arched rock with an impermeable cap makes an excellent trap for anything lighter than water that migrates upward through it. The same collision that dried the interior of Iran folded the southwest into one of the most productive geological structures on Earth. But go back north, and the plateau's rule reasserts itself in the hardest way it can. In the far northwest, held between mountain ranges, there is a lake with no way out. Urmia has no river draining it to any sea. It is fed by seasonal streams coming off the surrounding highland, and it loses water only one way, upward into the air. Everything the mountains ever sent it, minus what the sun has taken, is still sitting in it. Which is why it is brine. Salt carried in by every stream over thousands of years has stayed and concentrated, until the water became far saltier than any sea. No fish live in it, almost nothing does, apart from brine shrimp and the algae they graze, and the flamingos that come for the shrimp and turn the shallows into a feeding ground. At times, when the salinity rises far enough, the water itself turns red. A lake in a closed basin is a ledger, not a body of water. It records exactly what the mountains delivered and exactly what the sky removed. And when the two figures stop balancing, the lake shows it, in a receding shoreline and a widening ring of white crust where water used to be. Urmia has been considerably larger than it is now. That too is written on the ground around it. Now go to the opposite corner of the country, the southeast. Sistan and Baluchistan is the emptiest province in Iran. The population density falls to around 1 person per square kilometre, against 137 in Mazandaran on the same national map. Two things make it that way, and they contradict each other. Inland, there is the wind. From roughly June to September, the Sistan Basin is scoured by what is known locally as the 120-day wind, a hot, relentless northerly that blows for months with barely a break, lifting dust and moving sand across the basin floor. It fills the terminal lakes of the Hamun with sediment, and it strips them when they dry. Nothing about that landscape is stable from year to year. The lakes come and go with what the rivers bring. And then, 200 kilometres south, the ground meets the sea. The Makran coast is humid. It sits at sea level on the Arabian Sea, on the outer fringe of the monsoon system, and it takes moisture off the water. Air temperatures there in summer are lower than on the plateau, but the humidity makes them harder. Mangroves grow in the tidal creeks. The gando, the mugger crocodile, lives in the seasonal pools of the rivers behind that coast, the only crocodile in Iran. Humid at the coast, among the driest ground on the planet, a short drive inland. The mechanism is the same one operating everywhere else in this country. Coastal ranges stand between the sea and the interior. The moisture comes in off the water, hits the rise, and stops. Behind it, the shadow. Follow the rim around and it closes. In the northeast, the Kopet Dag runs along the frontier with Turkmenistan, and Mashhad sits in its foothills. The same address as every other city here, on the fan below the range, drinking what the mountain releases. Zagros in the west, Alborz in the north, Kopet Dag in the northeast, Makran and the Bashagard ranges in the south, running out to where the Zagros finally dives into the sea in a scatter of salt-cored islands. The ring is complete. It is not a metaphor. It is the shape of the country. And on the semi-desert inside it, on the fringe between the salt and the slope, one animal is still running. The Asiatic cheetah is the last of its kind on Earth. Every other cheetah alive is African. This one survives only here, on the arid steppe and desert margin of central and eastern Iran, in places like Turan and the Miandasht refuge. It is not a savanna animal, and it has not been for a long time. It hunts goitered gazelle and hare across open, stony semi-desert where cover is minimal and prey is thin on the ground, which means it must cover enormous distances between opportunities. It is lighter than its African relatives, paler, with a thicker coat for the cold nights the plateau delivers, even in summer. There are very few of them. A survey published around 2019, built from more than 12,000 camera traps set across its range, put the number at fewer than 30. Later estimates have gone lower still. The pressures are the ordinary ones. Prey has thinned. The distances the animal must cross are now crossed by roads, and vehicle collisions take individuals a population this small cannot replace. That is the situation as it stands. It does not resolve into anything. What remains is the wall itself, and the thing about it nobody sees from outside. The Zagros is the largest structure in this country. It runs from the borders with Turkey and Iraq in the northwest, down and across all the way to where it meets the sea in the southeast. And in the south, it widens into a band of parallel ridges roughly 200 kilometres deep. Not one wall, ridge, valley, over and over for the width of a small country. It is being built right now. Around 35 million years ago, the northern edge of the Arabian Plate came into contact with the Iranian bloc, closing the last of an ocean called the Neo-Tethys. That ocean had spent hundreds of millions of years accumulating sediment on Arabia's continental shelf. Limestones, marls, evaporites, 4 to 7 kilometres thick. When the two continents met, that sediment had nowhere to go but up. Crustal thickening began around 25 million years ago. The plateau behind it rose later, after 15 to 12 million, and the collision has not stopped. Arabia is still moving north into Eurasia at roughly 2.5 centimetres a year, and the Zagros and the Iranian plateau are still being pushed higher because of it. The country is not sitting behind a wall. The country is sitting on one that is still growing. Many peaks in the Zagros pass 3,000 metres. In the south-central section, several exceed 4,000. The highest of them is Zard Ku, the Yellow Mountain, around 4,200 metres, snow-covered for most of the year. And this is where the whole thing turns over. Winter weather systems reaching Iran come mostly from the west. They cross Turkey and Mesopotamia, carrying whatever moisture they've picked up over the Mediterranean and the Atlantic before it. And the first serious obstacle they meet is the Zagros. So the Zagros takes it. The rain and the snow come down on the western and southwestern flanks. The air that continues east onto the plateau has already given up most of what it was carrying, which is why the interior is dry and why the deserts are where they are. That is the wall doing the thing everyone assumes a wall does: blocking. But snow on a mountain is not lost water, it is stored water. The Zagros holds it through the cold months in a mass that runs the length of the country and then releases it in spring over weeks as the temperature climbs. Some of that melt becomes rivers. The Karun rises here, and the Zayande Rud, and the Des. Some of it soaks into the fractured limestone and moves through the rock as groundwater. And some of it emerges far out on the plains at the foot of the range, in the gravel of the alluvial fans, which is precisely where every qanat begins. So the wall that dried out the interior of Iran is the same wall that waters it. The mountains took the rain from the plateau and then handed a fraction of it back, on a delay, underground, at exactly the places where people could reach it. Every mother well in this country is sunk into water that fell as snow on a ridge the viewer would call a barrier. That is why Iran sits behind a wall of mountains, not because it was hiding, because there was nowhere else to be. The rim is not the edge of the habitable country. The rim is the source of it. The population did not spread out across the middle and stop at the mountains. It gathered against the mountains and left the middle alone, because the mountains are where the water is. Take the whole country together, roughly 90% arid or semi-arid, under 10% of the land, classed as arable, and the great majority of 90 million people packed onto the ring in the foothills, the intermontane basins, and the two coastal strips. The empty middle is not a failure. It is what is left over. And there are people here who never accepted a fixed address at all. The Bakhtiari are a lure people of the high Zagros, and for as long as anyone can document, they have solved the mountain by refusing to live in one place on it. The problem is simple, and the terrain makes it unavoidable. The lowlands of Khuzestan are warm enough to graze animals through the winter and scorched bare by summer. The high valleys of the Zagros are green through the summer and buried under snow all winter. Neither elevation will feed a herd for 12 months, so you use both. Twice a year, you move between them. And between them stands the range. Spring 1924. Haidar Khan leads roughly 50,000 people and something in the order of 500,000 animals out of the winter pastures and up toward the summer grass. Travelling with them are three outsiders: Marion C. Cooper, Ernest Schoedsack, and the journalist Marguerite Harrison. The first Westerners to make the crossing with the tribe, carrying a film camera. The first obstacle is the Karun. It is in spring flood, fed by the same snowmelt they are walking toward, and in places it is close to 1/2 mile across. There are no boats. There is no bridge. So they inflate goat skins, whole skins, sealed and blown tight, lashed under frames of branches to make rafts for the women, the children, and the weakest animals. The men go in individually, each holding a pair of inflated skins, and swim the herds across beside them. It takes about a week to move the entire nation from one bank to the other. Some do not come out the other side. Neither do a great many animals. That is understood before anyone enters the water. And then they reach Zard Ku, 4,200 metres of snow-covered rock, no visible trail, and 50,000 people at the bottom of it, most of them barefoot. The lead groups take out shovels and begin cutting a path. Not a route around, a path, dug through the snow, up the face, switchback by switchback, made passable one section at a time by sheer weight of numbers. Behind them, the column climbs. Men, women, children, goats, sheep, mules, cattle. Over the crest and down into the high valleys on the far side. The full journey runs about 48 days. And here is the part that reframes everything. Nobody was fleeing. There was no disaster, no war, no famine driving that column up the mountain. It was spring. That is what happens in spring. The crossing that a film crew risked their lives to record, and that audiences in 1925 watched as an epic of survival, was, to the people doing it, the commute. The film they made was called Grass. It is among the oldest surviving documentaries in the world, and it survives as the first outside record of what this range costs to cross. The scale of that particular migration is gone. Roads came, trucks came, a bridge went over the Karun, and the tribe no longer assembles 50,000 strong to walk. Families still move with their herds through those valleys, in smaller groups, on partly modern terms, over the same ground. But the reason has not changed at all. The mountain still has two climates stacked on top of each other, and it still refuses to feed anything year-round at a single altitude. The land set the schedule. The people kept it. There is a habit, when a place is far away, of reducing it to a single image and keeping that image for life. For this country, the image is usually sand. Flat, low, hot, undifferentiated, somewhere out past the edge of the map most people carry in their heads. It is a serviceable picture. It is also, in almost every particular, the wrong shape. The real organizing fact of Iran is not a desert. It is a mountain range, and then a second one, and then a third, arranged in a ring around a raised interior that is dry precisely because they are there. The deserts are downstream of the mountains in every sense that matters. So are the cities. So are the tunnels. So is the goat on the cliff and the cat that hunts it. Nobody names the Zagros when they think of this place. It is the largest thing in it. On the semi-desert of the interior, one more animal makes the same argument. The Persian onager is a wild ass, built for exactly this ground. Sandy-coloured, unmarked, heavier and faster than it looks, capable of 60 to 70 kilometres an hour in a sprint and able to hold 40 or 50 over long distances without distress. It lives in the open steppe and semi-desert of the plateau, in the reserves at Kar-Turan and Bahram-e-Gur and a few other pockets, on plains where an animal can see a threat coming from kilometres away and simply leave. Nothing out there can catch it, and it cannot go anywhere. Unlike some of its desert relatives, the onager needs to drink, and it needs to drink regularly. It cannot pull enough moisture from dry forage to cover itself, so an animal built to cross open country at 50 kilometers an hour spends its life orbiting a handful of springs and seasonal pools, never straying further from water than it can return in a day. perfectly equipped for the distance, permanently tied to the well, which is the whole country in one animal. Everything here is arranged around water that fell somewhere else. The snow lands on a ridge, and the city drinks it 80 kilometers away, months later, through a tunnel that a man cut by hand and never saw the far end of. The forest on the north coast has been standing since before the ice ages because a sea and a mountain agreed to hold the temperature between them. The salt in the middle of the map is the residue of every spring flood that arrived and never left. None of it is accidental. All of it is the same collision, still underway, 2.5 centimeters a year. It is easy to look at a wall of mountains and read it as a closing, a country shut in, cut off, held apart from the seas on all sides of it. That reading is available, and it is not entirely wrong. The passes are few. The ways in have always been countable. But it is worth remembering what the alternative would have been. Flatten the Zagros and the Alborz, and the winter systems cross unimpeded and keep going. No snowpack, no spring melt, no aquifer in the gravel at the foot of anything, because there is no foot of anything. No mother wells, because there is no water table shallow enough to reach with a shovel. No Isfahan, no Yazd, no Kerman, no Tehran. The mountains did not merely fail to prevent this country, they are the reason there is one. Perhaps that is the more honest way to read a wall. Not as the thing that shut a place off from the world, but as the thing that gave it something to hold, and made everyone inside it very good, very early, at not wasting a single drop of what came over the top. Thank you for watching. If you would like more journeys like this one, consider subscribing. Until the next one.